Hi everyone, welcome once more to Best Science Brain YouTube channel. Today we are presenting NECO 2024 solution to the specimen, and then we are looking at today the test for anion cation, which is known as qualitative analysis. Already we have done the video on endpoint determination, that is quantitative analysis or titration. We have done that in this channel, so you stream our videos to see that. But at this point in time, we're going to look at the test for anion and cation. In the NECO specimen for 224, we're provided with two chemical substances, C and D. So we're going to carry some tests on C and D and review the different ways by which questions can be asked on these two specimens, C and D. Then at the end of the experiment, we identify the components inside C and also inside D. So if you're not subscribed to the channel, the video is playing on your phone or on your system or on your whatever laptop. Go to the channels, you look down beneath the video, you see the channel's name, Best Science Brain. Beneath this video, you see the channel's name, Best Science Brain. Then you see the subscription button or icon. Tap on the icon only once and get subscribed to the channel. Share our videos to students that need it. Share our videos to people that need it to help someone to pass this examination. So let's go straight to the question. So we have C is a simple inorganic salt. D is an organic substance. Carry out the following exercises on C and D. Record your observations and corresponding inferences. Question AI. Add 10 cn cube of distilled water to C and stir thoroughly. I repeat, add 10 cn cube of distilled water to C and stir thoroughly. So let's go to the board and report our work. So under the test column, we report AI C plus 10 cn cube of distilled water. Report in past tense and stirred. So it's always good that report your work before you do the experiment. Report before you do the experiment. Observation is what's going to see when you do the experiment. So report when you read the question, report it before you go to the experiment, because if you don't report, you may forget what to report later. So let's go to the experiment now. So this is C. You can see written there. White crystals, C, all covered. So I'm going to open the test tube. And then I'm going to add water to C. So collect a reasonable amount of water and add up to more than half. They say 3/4 of the test tube is filled with water. You're not measuring the water. Just add a reasonable amount of distilled water. So when you added water, look for a stirrer, like a glass rod, and stir the salt. So you stir it until it dissolves. So continue stirring. Then you can as well shake the test tube to facilitate the process. If your hands are, if your thumb is clean, you can shake it. So you stir it. So as I stir, the test tube is getting hot. So do the practical, it's getting hot. And if any process where heat is liberated or where it's said to be exothermic, so I'm having a warm or hot sensation as I'm touching the test tube. So you can see the process. So you see that C had dissolved totally, clearly dissolved. So you can see that. So let me shake it a little. Then clear every insoluble substance. So C had dissolved clearly to give you a colorless solution. Okay, so let's go to the whiteboard. Observation, we now write C dissolved completely in water to give a colorless solution. Okay, that's observation that we have. Then we also write that the test tube felt warm to touch. So as I was doing it, I felt the sensation. So under inference column, you write C is a soluble salt. Full stop. Then you write the solution is exothermic because of the sensation of hotness felt in the process. Exothermic. So let's go to the second question. Question II says test the resulting solution from 2AI with litmus paper. Test the resulting solution from 2AI, the one we did after adding water, with litmus paper. So report the work on the board first. So AII, you now say solution from 2AI, that's this one done, plus litmus paper. You don't say C plus because C is no longer what you have the solution, no longer C. Solution, or you can say C aqueous in place of solution. This is allowed. C aqueous plus, or you can say, but without aqueous is wrong to say because C is a solid. Aqueous is same as solution of C. So that is okay. So we'll go to the experiment. So this is the solution of C from question 2AI. This is the red litmus paper. So I'll dip it inside of it and see whether there's going to be any change. So on adding red, there's no change on the red litmus paper. You can see that. So the next we pick the blue one and repeat the same process. The blue litmus paper. So on dipping the blue one, let's see what will happen. Just for a second. The blue one, you can see this one changed to red. That means this solution is acidic by changing blue paper to red. So they report our work on the board. So now I write observation, solution had no effect on blue litmus paper. On red litmus paper. But changed blue litmus paper to red. Look at the color, the two colors will be mentioned for you to score. Change blue to red. You must mention the two. So for you to inference, now say solution is acidic. Solution is acidic. So take few seconds to go through our work before we go to the next question. When I go to question III, says to 2Cn cube of solution from 2AI. The 2AI is the C plus water, remember? Add NaOH aqueous in drops and then in excess. To 2Cn cube of solution from 2AI, add NaOH aqueous in drops and then in excess. So let's go to the board. We now have AII, triple I, is a 2Cn cube of solution from 2AI, or you can say C aqueous, means the solution from 2AI, plus NaOH aqueous in drops. When reporting the chemicals, you must specify aqueous on them. That is very important. You don't write the formula only. But if you don't report it very well here, you're going to fail everything over there. So the chemicals must be specified with aqueous. Whatever chemical you're writing, there must be aqueous close to it, AQ. That means solution. So this C aqueous means we're using a solution of the number 1. So C dissolved in water. It's not 2CnK of C. C is a solid. We're using C in solution. That means C aqueous. So having done that, we'll go to the experiment. So we'll now collect 2CnK. We have little amount. This is the C aqueous. C dissolved in water. We'll collect little amount of it. That represents our 2Cn cube into a clean test tube. That's okay. That represents our 2Cn cube of C aqueous. Then we are now going to add sodium hydroxide, NaOH, freshly prepared. We're going to add it in drops, a little amount of it into this place. Just a drop. You can use the dropping pipette, or just add a little amount of it into it. So we are forming a kind of, you come closer, we have a kind of cloudy inside, hanging inside. That is called white gelatinous precipitate. So it's not pure white. It looks like his gum is hanging just below the meniscus. White gelatinous precipitate formed in drop. So let's report our work on the board. So observation, we have white gelatinous precipitate formed in drops of the chemical. The inference will write zinc 2 ion Zn2 plus, capital Z and small n, comma, and then we also write Al, aluminum 3 ion present. You don't say and, you say comma, because only one salt. So zinc or aluminum is logical, or aluminum present. You don't put lead because it's gelatinous. Lead is pure white or chalky white. So because of the word gelatinous, you remove lead. The next you're asked to do is you're asked to add the chemical again, sodium hydroxide, to this form in excess. To the PPT form, we're adding it in excess to it and see what's going to happen. So this is the white gelatinous precipitate formed. We're adding the chemical NaOH in excess to it to see whether it's going to dissolve or not. So you can see the white substances inside. So we'll now add more of the NaOH. So you see that the PPT gradually dissolves. So with time, you're going to dissolve. So you see that the PPT has dissolved. So gradually it's becoming colorless. No more solid hanging inside. So let's go to the board and report our work. Observation will now write white gelatinous precipitate dissolved to give a colorless solution. Then we'll go to the inference. Under inference now, we'll report also zinc 2 ion and also comma lead aluminum 3 ion, zinc 2 aluminum 3 ion present. So that is it. So take a minute to view our work as we go to the next question. So go to question IV that says to 2Cn cube of solution from 2AI, that is MC aqueous, add aqueous ammonia in drops and then in excess. To 2Cn cube of solution from 2AI, add NH3 aqueous in drops and then in excess. So go to the board. So question AIB says 2Cn cube of C aqueous plus ammonia aqueous in drops before we now go do the excess. So let's do this one first. So this is still our C aqueous. This is a clean test tube. So we'll now collect little amount to present our 2Cn cube of C aqueous. So a very little amount is okay. So that's enough. We'll now look for ammonia. So we have our ammonia here, freshly prepared ammonia solution. Remove the masking tape covering it, and then we'll collect little amount. They say add in drop. Just add little amount to C aqueous. So come closer to the camera. You see we have also white gelatinous precipitate formed inside the inside the test tube. So you can see that. So report our work. We now write observation: white gelatinous precipitate formed. And the ions that give us this kind of results are nothing but the same zinc 2 we observed before, or aluminium 3 ion, these 3 present. Lead was removed because of the word gelatinous. So the next, we have to add ammonia in essence. We now say plus NH3 aqueous in excess. So we're going to add more of ammonia to the white gelatinous precipitate that was formed. So this is the white PPT that was formed, the gelatinous PPT. This is ammonia. We're adding more of ammonia to this white PPT to see what happens, whether it's going to dissolve or not. So that is dissolving gradually. So you can see that the white PPT had dissolved. It's now very clear. So the white gelatinous PPT dissolved in excess ammonia. So they report our work. So here we report white gelatinous precipitate dissolved to give a colorless solution. So go to the inference table and write only zinc 2. Don't eliminate aluminium. Zinc 2 ion confirmed. So we are sure it's zinc that is present in the salt. So it's the zinc 2 salt. C is the zinc 2 salt. So you can look at our work, and then in a few minutes, so we can go to question V, AV. So now move to question V. It says to 2 CN³ solution from 2AI again, that is C aqueous. Add 1 CN³ of dilute HNO3, followed by 2 CN³ of silver nitrate, and then excess ammonia. To 2 CN³ of solution from 2AI, add 1 CN³ of dilute HNO3, followed by 2 CN³ of silver nitrate and excess ammonia. So let's go to the test. 2AV, 2 CN³ of C aqueous plus 1 CN³ of HNO3 aqueous. So if I write the chemical, I said specify aqueous on it. So dilute on it if it's an acid. So that is it. So we'll add this one before we add other chemicals. We're asked to add this one and also add silver nitrate. So let's start with this one first. So these are C aqueous. These are empty test tube. So collect just small amount that represent our 2 CN³ into the container or the test tube. So having done that, we're going to add HNO3 acid into it. So this is HNO3 fresh prepared acid into it. Remove the tap. We're now going to add it. As I add, you observe this place and see whether anything will happen. So we're going to add a little amount of the acid. You see, nothing happened. So there was no visible reaction. Look at it, the solution remains clear. No reaction, no PPT formed. So we report our work. Observation will write no visible reaction. Or in bracket to write no precipitate formed. And that will write in it. So any of these two can go. Then under inference, you write CO3, carbonate ion, CO3 2 minus, SO3 2 minus. The letters are all capitals because they're different elements. And then sulfide ion, S2 minus. These 3 ions, you write, they are absent because if they were present, they liberate a gas with acid. Since no gas was produced, no reaction happened, that means these ions are not in the C aqueous. So the next is we're asked to add, next line, we're asked to add 1 CN³ of silver nitrate, AgNO3. So we're going to add silver nitrate to this solution which we have formed in above. We are going to add silver nitrate to it. So that the mixture produced when we added HNO3. And here we have our silver nitrate prepared freshly. We just add a drop, a little amount of it. So you can see white or chalky white precipitate formed, not gelatinous. This is white produced. So report our work on the board. So observation will write white precipitate formed. So the ion that is present here will now write C, capital C, and small l, the negative. Chloride ion present. The next we are asked to add again a third chemical here. We are told to add aqueous ammonia in excess. So we're going to add ammonia to the white PPT produced and see what's going to happen. So this is the white PPT formed after adding silver nitrate. This ammonia, we'll add ammonia in excess to it. So you see that it's clearing little by little. Add more ammonia. So you see that the white PPT had dissolved in excess ammonia. So you have a colorless solution. All right. So now I write white precipitate dissolved to give a colorless solution. So now I write chloride ion Cl minus confirmed. So take a minute to view our work. As I'm looking at the work, we're going to also give you another version of this question. The question can be twisted, whereby you'll be asked to add silver nitrate first before HNO3. So we're going to see what's going to happen, how you're going to report your work. If you are told to add silver nitrate before HNO3, so what's going to be your report? Assuming that what we add first is silver nitrate. Added first. So what will be our observation? Are we going to observe no little reaction? No. If you are told to add silver nitrate first, the observation should be white precipitate formed. Because questions can be rearranged in different ways. White PPT formed. And your inference will no longer be carbonate and SO3 sulfide absent. Your inference now be CO3 2 minus and then Cl minus present. Please not and, comma. The comma means this or that, present. Then the next, they will tell you to add HNO3 letter. You add HNO3 letter, the white PPT formed above will remain insoluble. So now I write white PPT or precipitate remain insoluble. Remained insoluble. So what you now write will be, you now write Cl minus present. We eliminate carbonate because carbonate will dissolve in excess acid. So since remaining insoluble, we have chloride present. Then they will now tell you to add ammonia in excess. The same observation and inference we see follow as before. So take 1 minute to look at it and then compare this result now to the one we did before now and see the differences in the sequence of addition of the reagent and the differences in your observation, especially in this first and second one and the inferences. So the question BI says add 5 cl of distilled water to D and stir thoroughly. Add 5 cl of distilled water to D and stir thoroughly. So let's go to the board. BI says D plus 5 cl cube of distilled water and stirred thoroughly. So we have D plus 5 cm of distilled water and stirred thoroughly. So we're going to pick specimen D, add water to it and stir it, and then record the observation. So this is specimen D, also white in color, but not pure white, not like a crystal, it looks like a powder. So we're going to add water to D, this water, up to about half of the tube, and then use a stirrer, or if your thumb is neat, you can still use your thumb to close, and then stir. Shake it, you shake it, and then let's see what happens. Let me add more water to D. So we have the particles of D dispersed inside. You can see the particles are so tiny, dispersed inside the liquid, forming a kind of colloid, what we call the colloid, or a kind of emulsion, a colloidal suspension. So let's report our work. So we now have observation, particles of D were dispersed uniformly in water to give a colloidal suspension. So what will inference? Under inference, we now see that mixture of D with water is heterogeneous, or in brackets you say a colloid. So that is it. We'll now go to 2BII. Say to 2 CNQ solution from BI that the colloid produced before. Add 2 Cn cube of copper sulfate followed by 2 Cn cube of sodium hydroxide, aqueous, and heat. So let's go to the board report and then do the experiment. Now I have 2 Cn cube of mixture from 2BI. We are adding first copper sulfate aqueous, then followed by sodium hydroxide before we heat. So let's go to the experiment. That the mixture from D, and this is a boiling tube. Since we are going to heat, so I'm going to perform the reaction in a boiling tube. So I'm going to add the colloidal mixture into this place. So we have that enough quantity. We're told to add copper sulfate and sodium hydroxide. So add copper sulfate into it, and then we add also sodium hydroxide. Let's look for it. Okay, let's look for another one. So we have sodium hydroxide added into it as well. So we have a kind of blue, almost deep blue complex formed, or deep blue solution produced. So that's the solution. So we are seeing nothing inside of it. So we look at the board. We go to the observation. We go to observation and write deep blue solution formed or produced. Under inference, nothing yet. So we need to identify what is present. Then you don't go and say copper, because you added copper. So you're not identifying copper. The reagent you have contains copper 2 ion. So the next test is we're going to heat plus heat. We're going to heat this mixture and then report our work. So we started heating the mixture over the Bunsen burner. Go to heat until it boils and see whether there will be any change. So when you heat, you try to rotate the mixture. Don't keep it at one place so you don't burst. So you don't burst the don't burst the boiling tube. Move it over the fire. Keep it slanting away from your face and also away from your neighbor's face. So keep it slanting away from your face and away from your neighbor's face. So you see the color had changed. The color had changed definitely. The color had changed to a kind of violet or purple color, showing the presence of proteins. So you see the color had changed. So to somehow violent, if you heat more, the color will change. The violent color will appear more and become more significant. So let's go and report our work. So report plus heat, we say color of mixture turns violet, or you say in bracket purple, depending on the color you have. So here you write proteins confirmed. Proteins confirmed. So this is the result you have. So go through our work before we now go to another thing. Go through our report on the board before we now go to another aspect. So assuming that in this question here, we added water to D, because D is a proteinous substance. And you are told to add, instead of adding copper sulfate and NaOH, which is what's called the Burette test, instead of adding copper sulfate and the sodium hydroxide, you are told to add what's called Minion's reagent in place of this plus Minion's reagent. So what we expect, if it's a Minion's reagent, you are told to add. So with Minion's reagent and then plus heat, you're going to have red stains produced. Minion's reagent, and then you now say also proteins confirmed. So having done this, before we finalize this practical work on qualitative analysis, we're going to go back to C. That's C, that is to 2A, that is specimen C, which is zinc chloride. So specimen C, which is zinc chloride. We're going to perform that test on that C aqueous, that is C dissolving water. When the C was in water, we're going to use, so using silver nitrate now. We're going to use lead nitrate in place of silver nitrate and see what happens. So assuming that we have this question C aqueous plus, you have to add 2 Cn cube of lead 2 nitrate. Remember that C aqueous is what we use in question 2A, that is zinc chloride that contains zinc ion and chloride ion. You have to add lead nitrate to this, the solution of C mixed with water. So what do we expect in observations? So this is a clean boiling tube. That the C aqueous, so the C aqueous, we're going to add some small portion into this boiling tube. Then from the question we have on the board, we are told to add lead nitrate to C aqueous. So this is our lead nitrate. Let's see what will happen. Add lead nitrate to C aqueous and see what will happen. So we have a white precipitate formed inside it. So we'll now write observation, white precipitate formed. So in that place, the test will be using silver nitrate. They can still tell you to use lead nitrate in place of silver nitrate and the other chemicals. Silver nitrate, HNO3, and ammonia, they can use lead nitrate in place of it. So when you add lead nitrate, you write here white PPT form, you write here only chloride present, ion present. The next thing you're going to do, they will tell you to heat plus heat. So we're going to heat this white PPT that is formed. So let's go to the heating process. So we are heating the PPT the white PPT that is formed when we added lead nitrate over the Bunsen burner. We're heating the white PPT to see whether it will dissolve or remain soluble or remain insoluble on heating. So as I said, as you heat, you try to rotate the boiling tube over the Bunsen burner. Don't keep it at one place so that it will not burst. That is the precaution you should take. So let's heat it to boiling point and see what happens. And keep it away from your face. Keep it away from your neighbor's face also as well. So that is it. So you see what is happening. So at boiling point, the white solid had disappeared. So at boiling, the white PPT disappeared or dissolved on boiling. So I'll off the gas. I'll allow it to cool and see what happens on cooling. So here I'll report plus heat and I'll write white precipitate dissolved on boiling. Then they will tell you allow it to cool. Then they can now write uncooled or allowed to cool. So let's see for a few minutes we'll allow it to cool and see what's going to happen when it cools. So you see that on cooling, look at the bottom of the boiling tube, the white PPT reappears again on cooling. The white PPT reappeared again on cooling. So there it goes. Let's go to the board and report our work. Here we write white PPT or precipitate. Please use the full name, don't use the abbreviation. Reappeared on cooling. So for this one, white PPT formed, we still write lead 2 present. So that indicates lead 2 or chloride present still. Then here we write lead 2 ion from lead 2 chloride confirmed. So take a minute to go through our work before we now finalize this analysis. So let's analyze our work, the experiment we have done so far. C is zinc chloride given to you. And zinc chloride is soluble in water. All chlorides are soluble except some few ones like silver chloride, lead 2 chloride, and copper 1 chloride, and mercury chloride. So zinc chloride is soluble. So when we added water to it, we expect to dissolve in water as we observed in the AI part of the question. The II, we are told to add little part to it. So when you dissolve zinc chloride in water, it undergoes hydrolysis in water. Have zinc 2 ions placed from chloride ion, hydrogen ions placed from OH. So it undergoes hydrolysis to give you HCl and zinc hydroxide. This is a strong acid. This is a weak amphoteric base. So that is why when we added the newspaper inside the solution of in AII, it turned blue to red because of the effect of the strong acid that overcomes the strength of the weak base. So that is why the aqueous solution of zinc chloride, that is C, turned blue to red. Then going to question AII, triple I, we are told to add sodium hydroxide to zinc aqueous, which contains zinc hydroxide. So when we added sodium hydroxide to zinc hydroxide, which is the C aqueous, so we form a complex salt because zinc can complex with sodium hydroxide. So either the hydroxylated complex salt or the diazo complex salt. So you have this salt produced, which is soluble. So, but in drops, remain insoluble. This is in excess. In excess, let me make it clearer for you. To make it clearer, in that A triple I, when we add the sodium hydroxide to zinc 2 ion, the zinc 2 ion in this C aqueous will combine with sodium hydroxide give us zinc hydroxide, which is insoluble, which is the white gelatinous PPT. This is what you observe in drops. In drops. That is what you observe in drops. So, but in excess, so we added this chemical in excess, the zinc hydroxide, which is the white PPT, combines with excess NaOH to give us the complex salt, which is sodium diazozincate salt, which is soluble. So it's a soluble complex. So this is in excess. You get a complex salt. That is why in drops we have white gelatinous due to the zinc hydroxide produced. In excess, you form a complex salt, which is the sodium diazozincate, or you can have sodium tetrahydrozozincate too in complex as a soluble salt. When we added ammonia, in ammonia the same thing happens. When we added aqueous ammonia, that is equation AIV. We added ammonia to the zinc ammonium hydroxide, that is present ammonia. We also formed zinc hydroxide in drops with the white PPT, white gelatinous PPT. This is in drops. Then in excess, the zinc hydroxide also complexes with excess ammonia. In excess ammonia to also form similar salt as with hydroxide to give you zinc diazozincate salt solution, or you can see how zinc tetrahydrozozincate 2 solution. Any of these can be used. So that is it. In excess, these two ones are soluble. In drops, you form similar PPT as with sodium hydroxide. In excess, you form a soluble salt, complex salt, as in sodium hydroxide. So, having done that, we go to question BV. AV, sorry, the AV is when we are asked to add HNO3. We have HNO3. We are testing for anion. The anion is chloride ion. So we added HNO3. There was no reaction occurring because acid cannot liberate a gas from chloride. Then we added silver nitrate. We had to the chloride, we had silver chloride with the white PPT formed. So on adding AgNO3 to the chloride, which is present inside the zinc chloride. Then on adding ammonia later on to the white PPT, silver can complex with ammonia to give us a diamine silver 1 ion produced. So in excess, the white PPT dissolved because of the diamine complex formed. So that's what we observe in that question AV. Then going to question BI, D is milk. So D is milk. So that one will carry out the test using copper sulfate and sodium hydroxide with the burette test. You can see do the test using Millions reagent. So we have come to the end of these practicals on qualitative analysis NECO 2024. Remain connected to the channel, share our videos out, and the moderator of the channel, Dr. B. So remain connected to the channel, share our videos to your friends, to your colleagues. So we're going to bring you very soon the NECO physics, the instruction and the solution, and then we're also going to bring you WAEC alternative